Hello everyone, and welcome to Jam Academy. In this short lesson, I want to discuss the meaning of the word work. Now, the word work is one of those terms that is commonly used in our daily language that has a very different meaning from what we mean when we say work in physics or in science in general. Your dictionary will define work as any activity that stresses you or any mental or physical activity, maybe reading or riding a bicycle or even sitting and talking like I am doing right now. That falls under the meaning of work when we use the word work. But in physics, the word work really has a very precise meaning. Now, keep in mind that before I define what work really is, the concept of energy is very crucial in physics. But the definition of energy can be very abstract. To give you a very basic definition, taking into consideration a couple of assumptions, energy is simply defined as the ability of an object or system to do work. The ability of an object or system to do work. So energy is defined in terms of your ability to work. So the question really is, what is work? Probably anybody can state the law of conservation of energy that essentially says that energy can neither be created nor destroyed. In other words, the total amount of energy in the universe remains constant. But what then is energy? It is defined as the ability of an object to do work. So the question is, what is work? Now, the most basic definition that I will want to give you, and listen attentively, is that work simply is the transfer of energy. Let me say that again. Work is the transfer of energy into a system or out of a system by an external force or by an external agent. Understand that, by an external force or by an external agent. Keep that in mind. Work really is not a noun but a verb. It is energy in transit. Understand that it is energy in transit. There are two essential ways by which energy can be transferred into or out of a system. And that is defined by the first law of thermodynamics, which we will not talk much about it here. Now, energy can either be transferred by doing work or by heating a system. For example, when you boil water, you are transferring energy from the flames into the water by a process called heating. Now, but on the other hand, if I move this pen from one point to another, I am doing work on this pen. I do apply an external force that causes this pen to move. So energy is transferred from me to the pen. Otherwise, the pen itself will not be able to move. So even though work is a scalar quantity, it can be positive, negative, or zero. When energy is transferred into a system, the work done on that system is positive. But when energy is transferred out of a system, then the work done on that system is negative. If no energy is transferred into or out of a system, then no work is done on that system, then the work done will be zero. Now keep in mind that for work to be done, the point of application of the force must move. In other words, for work to be done, the point of application of the force must be displaced from one point to another. Let me give an example. We have a boy pushing a box. Initially, the box is at a position xi, and he applies a force that causes the point of application to move from the position xi to the position xf. So the displacement of the point of application of the force delta x is simply equal to xf minus xi. Now the work done by the force, capital W, is equal to the force, which in this case is in the direction of the displacement, multiplied by the magnitude of the displacement itself. So this gives us the definition of work. Recall that the force has to be in the direction of the force displacement. Now, force displacement is the displacement of the point of application of the force. Now, I'm going to give you another example. Suppose that you have a box attached to a spring. If you push on the box, what happens is that the spring compresses. So the point of application of the box changes. It moves from a position xi to a position xf, and the spring compresses. Now energy has been transferred from the boy to the spring. You can tell because if you let go of the box, the spring will spring apart. And clearly, that is an indication that energy has been transferred from the boy to the spring. And the energy is stored in the spring as elastic potential energy. This is another example in which the boy exerts a force on a very large stone, but there is no motion. In other words, the point of application of the force does not move, does not changes. There is no force displacement. Even though he is doing he's pushing the stone with a very large force and he is getting tired, he is not doing any work because there is no displacement of the point of application of the force. So before I sign off, work is the transfer of energy when an external force causes its point of application to be displaced. Let me say that again. Work is the transfer of energy when a force moves its point of application. So if there is no displacement of the point of application of the force, there will be no transfer of what? Energy, in which case there will be no work. In the next section, we will give you the mathematical definition of work and its physical implication. Thank you so much, and have a wonderful day. Bye-bye.